Welcome back, students. I hope all you understood what I have explained yesterday. Today, I am going to continue with ionization energy. Ionization energy is the energy required to remove an electron from its orbit, and it is given by ionization energy that is equal to plus z square by n square 13.6 electron volts, and it also can be written as ionization energy IE is equal to z square by n square R into H into C. These are very, very important relations for ionization energy. Okay. Next, Rydberg's formula. We know that when electron makes transition from any higher state to lower state, it emits a photon, and its energy is given by h nu is equal to ei minus ef. Ei is always greater than ef, and ei corresponds to the energy level ni, that is greater than nf. We know that ei ei is equal to minus z square or hc by n square, and ef, this is I, ef is equal to minus z square or hc by nf square. This is initial energy, this is final energy of final energy state. On substituting these equations in h nu, we get nu is equal to RC into 1 by N F square minus 1 by Ni square. This is the frequency of emitted photon, that means emitted spectral line. This gives the frequency of spectral line. This is RC because Z is equal to 1 for hydrogen atom. This is known as Rydberg's formula. This is Rydberg's formula. And wavelength is the spectral line, that means photon is given by 1 by lambda is equal to R into 1 by NF square minus 1 by Ni square. This is also known as Rydberg's formula. This gives the frequency, this gives the wavelength of emitted photon or spectral line. Next, we can see the Rydberg's formula for hydrogen spectral series. Rydberg's formula for hydrogen spectral series. In that first one, Lyman series, Lyman series is due to the transition of electron from any higher state to first orbit. Therefore, its wavelength is given by 1 by lambda is equal to R into 1 by 1 square minus 1 by n square. Here, Nf is 1 and Ni is equal to 2, 3, 4, etc. up to infinity. This can be taken as n. This is the wavelength for Lyman series. Next, for second one, Balmer series. Balmer series is due to the transition of electron from any higher state to second orbit. Therefore, here Nf is equal to 2 and Ni is equal to 3, 4, 5, etc. up to infinity. Therefore, its wavelength is given by 1 by lambda is equal to R into 1 by 2 square minus 1 by n square. Here, n is equal to 3, 4, 5 up to infinity. Next, third one, Paston series. Paston series is due to the transition of electron from any higher state, third orbit. Here, Nf is equal to 3 and Ni is equal to 4, 5, 6, etc. up to infinity. And its wavelength is given by 1 by lambda is equal to R into 1 by 3 square minus 1 by n square. Here, n is equal to 4, 5, 6, 7, etc. infinity. These are the wavelengths of hydrogen spectral series. Those are Lyman series, Balmer series, and Paston series. Next, we can discuss the de Broglie wavelength for electron in its nth orbit. De Broglie wavelength of electron in its nth orbit. And it is given by lambda is equal to circumference of the orbit in which electron is revolving divided by principal quantum number. Okay, this is very important relation. This gives the de Broglie wavelength of electron. Okay. Now, we completed our synopsis part. Let us move to discuss problem part. Okay, here first question is given if lambda 1 and lambda 2 are the wavelengths of the first members of the Lyman and Paschen series respectively, then lambda 1 is to lambda 2 is. We know that Lyman series is due to the transition of electron from any higher state to first orbit. Therefore, its Rydberg's formula is 1 by lambda is equal to R into 1 by 1 square minus 1 by n square. Here, n is equal to 2, 3, etc. up to infinity. For first line, this is for Lyman series. For first line of Lyman series, n is equal to 2. Therefore, we can solve this as 1 by lambda 1 is equal to R into 1 by 1 square means 1 minus 1 by 2 square. 1 by lambda 1 is equal to R into, this is LCM is 4, this is 4, 4 minus 1. Next we get 1 by lambda 1 is equal to R into 3 by 4. That is equal to 3R by 4. This is equation 1. Next, Paschen series is due to the transition of electron from any higher state to third orbit. Therefore, its Rydberg's formula is 1 by lambda is equal to R into 1 by 3 square minus 1 by n square. Here, n is equal to 4, 5, 6, etc. infinity. For first line of Paschen series, n is equal to 4. Therefore, 1 by lambda is equal to R into 1 by 3 square minus 1 by 4 square. This is lambda 2. 1 by lambda 2 is equal to R into 1 by 9 minus 1 by 16. 1 by lambda 2 is equal to R into LCM is 144. 16 minus 9, that equal to 16 minus 9 is 7 R by 144. Now we have to calculate lambda 1 is to lambda 2. Therefore, consider this is equation 1 and this is equation 2. Consider 2 by 1. Then we get 1 by lambda 2 into lambda 1 is equal to 7R by 144 into 4 by 3R. Here RR get cancelled. 4 1s are 4 3s are 4 6 are. Next, this can be written as 7 by 108. Therefore, lambda 1 is to lambda 2 is equal to 7 is to 108. Which one is the answer? Fourth one is the Answer. Second question, the ionization energy of lithium plus plus is, this is doubly ionized lithium ion. We know that ionization energy is equal to Z square by N square 13.6 R. Ionization energy is equal to Z square by N square RHC. This value, its value, RHC value is equal to 13.6. Okay, for lithium, we know that Z is 3. Its atomic number is 3 and its electron lies in first orbit. That means N is equal to 1. By substituting these values, we get IE is equal to 3 square by 1 square into RHC. Here, ionization energy is equal to 9 RHCr. 9 HCr. Which one is the answer? First one, 9 HCr. The ionization energy of lithium double plus is equal to 9 HCr. Okay, we can move for next question. Electrons in a certain energy level, N is equal to N is equal to N1 can emit 3 spectral lines. When they are in another energy level, N is equal to N2, they can emit 6 spectral lines. The orbital speed of the electrons in the two orbits are in the ratio. We know that the number of spectral lines emitted by the electron when it makes transition from one energy level to ground state, that is N is equal to N into N minus 1 by 2. These are the number of spectral lines or photons emitted by the electron while making transition. Okay, here they given N1, 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 3 given N1 is equal to 3, N1 square minus N1 by 2. On cross multiplication, 6 is equal to N1 square minus N1. On rearranging this, we get N1 square minus N1 minus 6 equal to 0. This equation can be written as N1 square minus 3N1 plus 2N1 minus 6 equal to 0. These both equations are same. Here N1 is common, N1 into N1 minus 3 plus here 2 is common, N1 minus 2 3s are, that equal to 0. Again here N1 minus 3 is common into N1 plus 2, that equal to 0. Here n1 minus 3 equal to 0 or n1 plus 2 equal to 0. Taking only positive values, n1 is equal to 3. n1 is equal to 3. Next, here they given n2 is equal to 6. Again, from formula, n2 is equal to n2 into n2 minus 1 by 2. They given n2 6. 6 is equal to n2 square minus n2 by 2. 12 is equal to n2 square minus n2, on rearranging n2 square minus n2 minus 12 is equal to 0. This equation can be written as n2 square minus 4n2 plus 3n2 minus 12 is equal to 0. Again, these two equations are same. Here, n2 is common. n2 into n2 minus 4 plus here 3 is common, n2 minus 3 fours are that equal to 0. Here n2 minus 4 is common, n2 plus 3 that equal to 0. Here n2 minus 4 equal to 0 or n2 plus 3 is equal to 0. Taking positive value, n2 is equal to 4. Here uh, energy levels we found n1 equal to 3 and n2 equal to 4. Again, they ask for ratio of velocities. That's why we know that velocity of electron in nth orbit is equal to Ze square by 2 epsilon naught n into h. Here, Vn is inversely proportional to n. Therefore, V1 is inversely proportional to 1 by 3 and V2 is inversely proportional to 1 by 4. Considering V1 by V2, we get 4 by 3. 4 by 3 is the answer. That means 4 is to 3 is the answer. That means first one. Okay, I think you understood this problem. Next, we can move for fifth question. Solar spectrum is an example for, yesterday we already discussed about this. Solar spectrum is line absorption spectrum. In solar spectrum, we can see Fraunhofer lines which are superimposed on continuous spectrum. Therefore, solar spectrum is line absorption spectrum. Which one is the answer? Second one, line absorption spectrum. The ratio of minimum wavelengths of Lyman and Balmer series will be, we know that for Lyman series, the Rydberg's formula is 1 by lambda is equal to R into 1 by 1 square minus 1 by n square. Here n is equal to 2, 3, etc. infinity. And for that of Balmer series, we know Rydberg formula 1 by lambda is equal to R into 1 by 2 square minus 1 by n square. Here n is equal to 3, 4, etc. up to infinity. Again, we know that when electron makes transition from one energy level to another energy level, it emits a photon whose energy is equal to energy difference between two states, EI minus EF. Here EI is greater than EF. And it shows that frequency of photon is directly proportional to EI minus EF. Again, this implies wavelength of the photon is inversely proportional to EI minus EF. EI minus EF means difference in energy. This is difference in energy states. Difference in energy states, and this is the wavelength of the emitted photon. If energy difference increases, wavelength decreases, and it becomes minimum for maximum energy difference. Maximum energy difference. That means for maximum energy difference, wavelength of the emitted photon or spectral line is minimum. Therefore, for maximum energy difference, n is equal to infinity for both Lyman series and Balmer series. We should take n is equal to infinity for minimum wavelength. Therefore, 1 by lambda minimum of Lyman series is equal to R into 1 minus 1 by infinity. This is equal to 1 by lambda minimum of Lyman series is equal to R. This is equation 1. And for this 1 by lambda of minimum of Balmer series, that is equal to R into 1 by 4 minus 1 by infinity. 1 by lambda minimum of Balmer is equal to R into, this becomes 0. 1 by infinity becomes 0. Therefore, R by 4. This is equation 2. We have to calculate for the ratio of minimum wavelengths of Lyman and Balmer. Therefore, you consider 2 by 1. Equation 2 divided by 1. We get 2. Second equation is 1 by lambda minimum of Balmer into that of lambda minimum of which one? Lyman. That is equal to R by 4 into 1 by R. Lambda minimum of Lyman series become 1 by R. Here R get cancelled. 1 by 4. 1 by 4 is equal to 0 0.25. 0.25 is the answer. That means fourth is the answer. Fourth option is answer. Okay, next we can move for next question. Here they asked for continuous emission spectrum is produced by first one, incandescent electric lamp. Incandescent electric lamp produces continuous spectrum. This produces continuous emission spectrum. Mercury vapor lamp produces line emission spectrum. LES means line emission spectrum. Sodium vapor lamp also produces line emission spectrum. Sun produces line absorption spectrum. LAS means line absorption spectrum. Here continuous emission spectrum is produced by incandescent electric lamp. Next question. Hydrogen atom from excited state comes to the ground state by emitting a photon of wavelength lambda. If R is the Rydberg constant, the principal quantum number n of the excited state is. Hydrogen atom from excited state comes to the ground state. Here, wavelength they asked 1 by lambda is equal to R into 1 by NF square minus 1 by Ni square. Here NF is means final state is ground state. Ground state means that equal to 1 and Ni is we take for that as N. 1 by lambda, then 1 by lambda is equal to R into 1 by 1 square minus 1 by N square. This can be written as 1 by lambda R is equal to 1 minus 1 by N square. And rearranging that, we get 1 by N square is equal to 1 minus 1 by lambda R. Here 1 by N square can be written as taking LCM lambda R minus 1. Then N square becomes the reciprocal of this lambda R by lambda R minus 1. I have to take for N, that is equal to square root of lambda R by lambda R minus 1. Is there any answer like that? Yes. First one, square root of lambda R by lambda R minus 1. First one is the answer. Next. Line, the spectrum of an oil flame is an example for, again, this is an example for continuous emission spectra. Okay, answer is continuous emission spectra. Spectra of oil flame consists of large wavelengths. Large wavelengths means wide range of wavelengths that consists of wavelengths from IR to, not IR, UV to IR. UV to IR without any spacing between them. Therefore, oil flame produces a continuous emission spectra. . An electron is moving in an orbit of a hydrogen atom from which there can be a maximum of 6 transitions. An electron is moving in an orbit of another hydrogen atom from which there can be a maximum of 3 transitions. The ratio of the velocity of the electron in these two orbits is, we already solved the question like this. First one, n is equal to 6. And for second one, second transition, n2 is equal to, what is that one? 3. We know that n is equal to n into n minus 1 by 2. Therefore, here 6 into n1 into n1 minus 1 by 2, that becomes 12 into n1 square minus n1. This can be written as n1 square minus n1 minus 12 equal to 0. That equation can be written as n2 square minus 4n2 plus 3n2 minus 12 equal to 0. Again, here n2 is common. N2 or n1, sorry, n1 minus 4 here plus 3 into n1 minus 4, that equal to 0. n1 minus 4 is common. n1 plus 3, that equal to 0. Taking only positive values, n1 is equal to 4. Again, for this, n2 is equal to n2 into n2 minus 1 by 2. n2 is 3. 3 is equal to n2 square minus n2 by 2. 6 is equal to n2 square minus n2. n2 square minus n2 minus 6 equal to 0. This can be written as n2 square minus 3n2 plus 2n2 minus 6 equal to 0. Again, here n2 is common. n2 minus 3. Here 2 is common. 2 minus 3. Again, here n2 minus 3. This is n2. n2 minus 3 is common here. n2 plus 2 equal to 0. Taking positive values, n2 equal to 3. We know that again velocity is equal to epsilon naught, not epsilon naught. Vn is equal to Ze square by 2 epsilon naught nh. Vn is inversely proportional to 1 by n. Therefore, V1 is inversely proportional to 1 by 4 and V2 is inversely proportional to 1 by 3. Consider V1 by V2, that is equal to 3 by 4. 3 by 4 is the answer. This one, fourth one is the answer. Here they given nu1 is the frequency of the series limit of Lyman series. Nu2 is the frequency of the first line of Lyman series, and nu3 is the frequency of the series limit of Balmer series. Then which relation is correct? Okay, they given for Lyman series. We know that Lyman series frequency is equal to RC into 1 by 1 square minus 1 by n square. Here n is equal to 2 or 3 up to infinity. For series limit n is equal to infinity. Therefore, nu1 is equal to RC into 1 by 1 means 1 minus 1 by infinity, that equal to 0. Nu1 is equal to RC. That is equation 1. Next, they given nu2 is the frequency of the first line of Lyman series. For first line, this is for series limit. This is for series limit. Series limit n equal to infinity. For first line, n equal to 1. Then n equal to not 1, that is 2. Nu2 is equal to RC 1 by 1 square minus 1 by 2 square, that equal to RC into 1 minus 1 by 4, that equal to RC into 4 minus 1, that equal to 3 RC by 4. This is equation 2. Nu2 is 3 RC by 4. Next, nu3 is the frequency of the series limit Balmer series. We know the Balmer series. Rydberg's formula is 1 by lambda frequency. They asked. RC into 1 by 2 square minus 1 by n square. For series limit, here n is equal to 3, 4, etc. infinity. For series limit, n is equal to infinity. Therefore, nu3 is equal to RC into 1 by 4 minus 0, that equal to nu3 is equal to RC by 4. This is equation 3. Consider equation 2 plus 3. We consider equation 2 plus 3. Then we get nu2 plus nu3, that equal to 3 RC by 4 plus RC by 4, that equal to 3 RC, LCM is 4, 3 RC plus RC, 4 RC, 4 get cancelled, that is equal to RC. RC is equal to equation 1, that is nu1. Nu1. Here we get nu1 is equal to nu2 plus nu3. This can be written as nu1 minus nu2 equal to nu3. Nu1 minus nu2 is equal to nu3 is the answer. That means first one is the answer. Next, we can move for the next question. The de Broglie wavelength of the electron in the ground state of the hydrogen atom is. The radius of the first orbit of hydrogen atom is given, that is 0.53 angstrom. De Broglie wavelength lambda is equal to 2 pi r by n. For first orbit, n is equal to 1. That means ground state, n equal to 1. Then lambda is equal to 2 pi. R is given. What is the R value? 0.53 angstrom. Lambda is equal to 2 into 3.14 into 0.53. Lambda is equal to 2 4s are 8, 2 1s are 2, 2 3s are 6 into 0.53. ಇದಕ್ಕೆ ಹತ್ರ ಆಗಿರುವಂತ ಆನ್ಸರ್ that is 3.33 angstrom. After the multiplication of this, we get lambda is equal to 3.33 angstrom. Second one is the answer. Next question. Rutherford's atomic model could account for. It does not account for stability. It does not account for origin of spectra. It accounts for positively charged central core of an atom. It does not account for concept of stationary orbits. Third one is the answer. When an electron jumps from orbit n is equal to 2 to n equal to 4, then wavelength of the radiations absorbed will be. Again, we know that Rydberg's formula 1 by lambda is equal to R into 1 by nf square minus 1 by ni square. Here, transition is from lower energy to higher energy. Therefore, here nf and ni can be interchanged. Therefore, 1 by lambda is equal to R into 1 by ni square minus 1 by nf square. Ni is 2 and nf is 4. Therefore, 1 by lambda is equal to R into 1 by ni square means 2 square minus 1 by nf square means 4 square. That equal to R into 1 by 4 minus 1 by 4. 4s are 16. 4 square is 16. Next, that is equal to R into 16 LCM. 4 minus 1. That is equal to 3R by 16. 1 by lambda is equal to 3R by 16. Lambda is equal to 16 by 3R. 16 by 3R. First one is the answer. Next question. The question is repeated. Sixth question is same. The ratio of minimum wavelengths of Lyman and Balmer series will be. Answer is 0.25. Already we solved this one. Which one is the answer? Second one. 0.25 is the answer. Seventeenth question. If n is the orbit number of the electron in a hydrogen atom, the correct statement among the following is. First one, electron energy increases as n increases. We know that energy of electron in nth orbit is equal to Z square by N square 13.6. Here as N increases, energy also increases. First one is the answer. Electron energy increases as N increases. Spectrum of sunlight is an example for sunlight spectrum is example for line absorption spectrum. Solar spectrum is example for line absorption spectrum. In hydrogen atom, electron excites from ground state to higher state. Ground state to higher state. Energy state and its orbital velocity is reduced to 1 by third. That means VH is equal to 1 by 3 of VG of its initial value. The radius of the orbit in the ground state is R. The radius of the orbit in that higher state is. You take principal quantum number in ground state as Ng, for higher state Nh. Here Vh is velocity in Nh and Vg, this is Vh. Vg is velocity of electron in ground state. This is Nh. Okay, we know that this can be written as Vh by Vg is equal to 1 by 3. This is equation 1. Again, we know that velocity of electron in nth orbit is equal to Ze square by 2 epsilon naught Nh. Here Vn is inversely proportional to 1 by N. Therefore, this can be written as Vnh is equal to 3 and Ng is equal to 1. Vh is inversely proportional to 3. That's why Nh, higher energy state is 3. Ground state is commonly 1. Again, we know that radius of nth orbit is equal to epsilon naught n square h square by pi m z e square. Here Rn is directly proportional to n square. Consider Rh by Rg that equal to n means nh means 3 square by 1 square that equal to 9 by 1. They given that radius of the orbit in ground state is R. Therefore, RH by R is equal to 9. Then RH is equal to 9R. 9R is the answer. Fourth one is the answer. The ratio of the magnetic dipole moment of the to the angular momentum of the electron in the first orbit of hydrogen atom is, we know that gyrometric ratio, that is ratio of magnetic dipole moment to angular momentum of electron in its orbit, that is equal to E by 2m. First one is the answer. Next question. Pick out the correct statement from the following. First one, mercury vapor lamp produces line emission spectrum. This is also right one. Mercury vapor lamp produces line emission spectrum. Second one, oil flame produces line emission spectrum. This is wrong. Oil flame produces continuous emission spectrum. Band spectrum helps us to study molecular structure. This is right. Band spectrum is due to the molecular substances only. Therefore, band spectrum helps us to study the molecular structures. Next, sunlight spectrum is an example for line absorption spectrum. This is also right one. Here, they asked for one correct statement, but they given three correct statements and one wrong statement. Therefore, the questions should be like this. Pick out the wrong statement from following. Then second one is the answer. Okay, next. Questions na ನಾಳೆ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ.